Hi, welcome back to the lecture. Let's take a look at a couple service discovery solutions that you might encounter in the marketplace. The first one is Apache Zookeeper. And this was originally a project that came out of Yahoo, and it's now part of the Apache Foundation. You'll find Zookeeper used in quite a few projects in the marketplace. I know that the Hadoop ecosystem used Zookeeper, might still use it today. You'll also find another solution called etcd, and etcd is a distributed key value store that you can utilize for storing shared configuration information. It was originally written and maintained by the Core OS team. They wrote it in the Go programming language, and you'll commonly find etcd used in container cluster platforms like Kubernetes. We also have Consul. Consul was designed by HashiCorp. It's leveraged as a service discovery system, and it's also used quite heavily as a key value store. Of course, AWS offers a number of service discovery services that you can use in your platform. We have the AWS Systems Manager Parameter Store. Parameter Store basically is a key value data store that is provided as a feature by the AWS Systems Manager service. And the Parameter Store service allows you to store strings, it allows you to store lists of strings and secure strings, so essentially encrypted strings. And there are sort of two different tiers that are available at the time of this video recording. There is the standard tier, which allows you to store up to 10,000 parameters, and each key value that you store can be up to 4 kilobytes, and that is a free service, which is great. And I've used this free parameter store service extensively over the past few years. There's also an advanced tier available if you need to store more than 10,000 parameters, if you need to store larger parameters. And you can also enable a high throughput mode, because the standard parameter store service is API rate limited. And if you have a really high transaction application that is sending API requests to Parameter Store frequently, then you might need to enable high throughput, which allows you to make up to 1,000 transactions per second with Parameter Store. So again, Parameter Store is a key value store. And how would you use it? Well, here's a simple Python code example where we have some data that we are storing in a parameter, and we want to retrieve that data. We're using the Boto 3 library, which is the AWS SDK for Python, and we are getting a parameter. We are getting a parameter called myParameter. And AWS will respond back with a JSON response, giving us the value that is stored in that parameter. So we can store things like service endpoints in Parameter Store. We can store secrets in Parameter Store. It's a really convenient, centralized key value store that our services can communicate with. Another AWS service is the Secrets Manager service. And this, like Parameter Store, is also a key value data store. And it's specifically designed to store sensitive data, things like API access tokens and passwords, encryption keys. So it stores all of this data in an encrypted format. You can store multiple values in Secrets Manager. So each key can have multiple values, and those values may be versioned. It's also tightly integrated with a variety of different AWS services like RDS and Redshift and DocumentDB, amongst other services. Well, so how is Secrets Manager different than Parameter Store? It's probably what you're asking yourself, because both are key value stores, both can store encrypted confidential information. Probably the biggest two big differences. One is the integration, the automated integration that Secrets Manager has with a variety of other AWS services. But most importantly, Secrets Manager allows you to automate key rotation, meaning that you might have something like a database password that's stored in Secrets Manager. It's stored in encrypted format, and your application is requesting this password from Secrets Manager. Well, what if you want to rotate that password? What if you want to change that password to the database every week or every month? You want to rotate that. How would you do that? Well, you could do it manually, but that would be, kind of a painful task. Or you could use this automated key rotation mechanism built into Secrets Manager. And what that will do is it will automatically update the database server password, and it will store that updated password in Secrets Manager so that applications which are requesting it can retrieve it. It can retrieve the updated password. So it's a really handy mechanism. Secrets Manager comes with a little bit of a price, though, because Parameter Store was free up to 10,000 parameters. Secrets Manager, you pay essentially 40 cents per secret or per key per month. So there is an expense associated with it. Here's an example of how you might access Secrets Manager using Python code. Here we're using the Boto3 library to talk to Secrets Manager, and we are looking for a secret, a key called company.financial.database. And Secrets Manager will respond back with JSON that includes it includes a secret string, which is a certificate and a passphrase for this database. And the last service I want to talk about that's available to us from AWS is a relatively new service at the time that this video was recorded. And this is AWS Cloud Map. Cloud Map is Amazon's version of the centralized service discovery solution, and it's implementing that sort of. It helps you build that sort of client-side pattern where applications can register themselves with Cloud Map, and then other services can query Cloud Map to find the location of services that they need to communicate with. Your applications can query Cloud Map using a variety of mechanisms. They can use an SDK like Boto3. They can use the AWS API, And they can also use DNS. So this is a kind of an interesting way, it's sort of a hybrid of leveraging a centralized service discovery mechanism along with a more traditional service discovery mechanism in DNS. And the benefit there is that you might have a traditional application. It doesn't know how to talk to Cloud Map, but it does know how to talk to DNS. And so it can still continue to leverage DNS as a service discovery mechanism. How does Cloud Map work? Well, we'll see a more detailed example of this later in the lecture, but there are sort of two different components that you need to be aware of. First is, when you configure Cloud Map, you start by defining a namespace. And basically, a namespace is a way of logically grouping together services. And so the namespace is something that you invent. Think of it as sort of like the domain for Cloud Map. And when you set up a namespace, you also tell Cloud Map how it's going to discover instances, how it's going to discover services. And it can discover services leveraging the API. It can also leverage the API and DNS. You sort of have to make a decision up front as to how your services are going to leverage Cloud Map. If they're just going to leverage the API, or if they're also going to leverage DNS on top of, as well as the API. The second sort of major component of Cloud Map is a service. And when you define a service, the service is associated with that namespace. You're basically creating a template that you're going to use to register service instances. And these service instances could be things like EC2 instances. They could be containers that are running in ECS Fargate, as we'll see here later in the lecture. So they're a way to sort of register a service with the Cloud Map namespace. And when you create the service, you specify what type of IP routing that you're going to use, especially if you are using something like DNS. And you can optionally define a health check as well. And so this is sort of like health checks for application load balancers, where the Cloud Map service can pull the service instances which are defined within that namespace. And so the Cloud Map can pull those services to understand if the service is healthy or not. If the service is healthy, then it will stay registered within Cloud Map. But if the service is unhealthy, then Cloud Map can actually remove that service from the Cloud Map registry. And the last thing that you define as part of a service configuration are attributes. And you can think of attributes as being sort of like the values which are returned when services query Cloud Map. So you have one service that is querying Cloud Map looking for another service. And Cloud Map could return something like an endpoint address, a web address. And that endpoint address is an attribute. And what's kind of cool is that Cloud Map can return multiple attributes for a given service. So like Cloud Map could return the endpoint address of the service. It could return the version of the service. That could be really helpful if you're working in a platform where you have multiple versions of the same service running, and you want to sort of discover the latest version or a specific version of a particular service. Here's an example using the AWS CLI, where we're querying the service discovery service and we are trying to discover the instances associated with a namespace called MyApp. And we're looking for the web service that is that is part of the MyApp namespace. And the service discovery returns a JSON response, and it is giving us the endpoint for that web service. So you can see this in an attribute here. One of the attributes is the URL that an application could use to communicate with that particular service.